In this video, we're going to work through 3 examples of rearranging or solving algebraic equations, solving for an unknown variable. The first example that we're going to look at, and these examples you can place into your notebook, the first example that we're going to look at is if we have the following algebraic equation. Now, we're going to start transitioning into looking at variables that actually stand for something. So instead of x, y, and z, we're going to be looking at pressure multiplied by volume is equivalent to or equal to the number of moles multiplied by the gas constant multiplied by the temperature. Now, right now, we don't have an understanding of what the term pressure or volume or number of moles or gas constant or temperature mean right now, but we will be able to solve this variable, or solve the equation for the unknown variable. Now, what I'm asking for in this problem is solve for temperature. We want to solve this equation for temperature. There are 2 rules when solving for an unknown variable. The first is the variable must be on top of the equation, and secondly, the variable must be by itself on that side of the equation. Previously, we talked about you could take this equation and draw a dotted line right through the equal sign to have a left side and a right side. We could also take this side and divide it by 1 and divide this side by 1, and it would not change anything. When we do that, you can clearly see there's a left side and a right side, and clearly see the right side has a top and bottom, and the left side has a top and bottom. The variable that we're trying to solve for is temperature, which is right here. And the rule number 1 is the variable that we're trying to solve for must be on top of the equation. Doesn't matter whether the left side or right side's got to be on top. It's already on top, so I don't need to move this. I get students moving this temperature down to the bottom of the other side, and I say, well, why did you move that? They say, well, you always move the variable when you start. No, you don't. If it's already on top of the equation, you leave it right there. But there are 2 variables that do need to move. The variable must be by itself, whatever side of the equation it's on. So here's the temperature that we're trying to solve for. We need to move the number of moles, N, and R to the other side. The rule is, and this is the paragraph here, when you are moving, you move to the opposite. Math folks call this cross multiplying. So I'm going to move N from the top down to the bottom of the left, and I'm going to move R from the top right down to the bottom left. I cross multiply them. So if I rewrite all of this, it looks like this: pressure times volume over 1 times N times R equals, those crossed out and moved down, temperature on the top over 1. Now that's a messy way to write that equation, so we'll just take the left side and the right side and just switch them, which we are allowed to do. So temperature is now equal to pressure times volume over number of moles times R. That's our final equation. When we take this equation and we are asked to solve the equation for the unknown variable temperature, we end up with temperature equals pressure times volume over N and over R. One of the things that we would need to be careful of when putting actual numbers and units in is a lot of students will put the number of pressure multiplied by volume divided by N and then multiplied by R. But because N and R are both on the bottom, you have to divide by both of them. So it's pressure times volume divided by the number of moles, N, and divided by R. Some students like to multiply these 2 to get a number, multiply these 2 to get a number, and then you just take that number and divide it by that number. That's perfectly fine. But if you're going to do it all in one step, this times this divided by N and divided by R, because R is on the bottom of the equation. For example number 2, if the equation is written like this, density is equal to mass divided by volume. A lot of times you'll see this slash as a divided by instead of a horizontal. I always like to rewrite the equation to show the horizontal divided by so that I can clearly see that m is on the top and v is on the bottom. If they're asking us to solve for m, we see that m is on top of the equation. I don't need to move it anywhere, but I need to make sure it's by itself, so I have to move v to the other side. So I cross out v from the right bottom and move it up to the left top. So my equation becomes m equals d times v when I solve for m. If I was solving this equation for v, d is equal to m over v. But let's say they said solve for v. The first thing I would notice is that v is on the bottom, and that's not allowed. So I would need to move it to the top. So I'd cross it out, move it to the top. And now that it's on top of the equation, I need to get it by itself. So I move d from the top to the bottom. So now volume equals mass divided by density. The rule is whatever variable we're solving for must be on top of the equation. Does not matter whether left or right. And then once it's on top, it's got to be by itself. My final example involves this equation. P1 over T1 equals P2 over T2. And let's solve for temperature number 2. So the first thing we recognize is that the temperature is on the bottom of the equation. That's not okay. Temperature has to be on the top. If we were solving for P2, it's perfectly fine. P1, perfectly fine. They're both on top. But if we were solving for T1 or T2, they're both on the bottom, so we'd have to move them. So we move it from the right bottom up to the left top. This is called cross multiplying in your math classes. Now T2 is on top of the equation, which is great. That's what we need. Step 1, the variable that we're solving for must be on top of the equation. But secondly, the variable must also be by itself. So it's not by itself. It's got P1 and T1 over. So if it's on the top left, it moves to the bottom right, cross multiplying. Our invisible line, now visible, is there, separating the left side and the right side. If it's on the bottom left, it moves to the top right. So now my T2 all by itself is equal to P2 times T1 over P1. That's my final equation when I rearrange the equation and solve for the unknown variable T2. Now T2 is equal to P2 times T1 over P1. And I would have a set of numbers with units that I would put in, and I would take P2 multiplied by T1 and then divide it by P1. I hope this helps in understanding how to rearrange equations and solve for the unknown variable.